All right, generally, all the labs that you do, after you complete the lab, you will have to make a Word document, put all those details in, and then submit it on Rockspace. Okay. Now, what is supposed to go into your lab report is what I'm trying to say. Well, the lab report, well, it's a Word document. It should have the title here on the top. You can make the title any size of font. It should be presentable, that's all. There's no rule as to what size of font should be used, how much space, all those things are not important. You need the title, which is neatly written down. I mean, of course, title should be bigger than the rest of the stuff. Normally, what font size do you use? Approximately to 12.
12, right?
So you can actually make it slightly bigger for that one. And even the titles, the subtitles over here can be bigger than the rest of it. And again, there is no format that I'm looking at, but it should be presentable. Okay? Like when you're making PowerPoint, do you actually follow any spacing stuff and all that? You don't. So just like that, you want to present it well. That's the title. And you write the experiment here, experiment number, and then the date, and your name that goes there. And if you're working in a group, which will be the case for most experiments, you will write your group. So who else worked with you? Okay, that is of course your name there. And here you put down who else worked with you so that I know the data can be matched up, but not the rest of the stuff. Okay, so the data can be common, the group. And after that comes the aim. Okay, aim of the experiment. What is it? It is telling what you're going into the lab for, what are you trying to achieve. That's the aim. So in this particular experiment, you're going to study the principle of moments. So your title is going to be Principle of Moments. Moment of a force. Moment means a turning effect. So moment of a force is what we call as torque. Okay? Moment of a force. So the word moment means turning effect. This word moment means turning effect. You know, the other moment is like instant of time, right? But this is the physics meaning of moment means turning effect. So when you want to turn a tap, you're creating a moment because by applying a force. All right. So moment of a force is what we call as torque. So principle of moments is the title. So you're studying all about torque and you're going to use the principle of moments. So the aim of this experiment, you can write down right now. The aim of the experiment is to study the principle of moments. To study the principle of moments and determine and use it to determine the following. So you're going to determine these. To study it, to use the principle of moments and determine, one, you're going to determine the mass of meter stick. You're going to determine the mass of the meter stick. Two, you're going to determine the mass of an object. Mass of an unknown object. And number three, you're going to find the relative density of this, the relative density of this object. These are the three objectives. Got it? These are 3 objectives. Right?
Yes.
We'll just show you the principle of what.
Moments. Moment, here it is. moment. Yeah,
For the date, we put the date we did the lab or the date it's due.
the date you did the lab. Yes.
So this is all for the aim, correct?
Oh, these are all going into the aim. Yeah, I'm just writing only the headings, but I'm explaining to you what you're supposed to be doing. Yes.
What is the experiment number?
1. How many experiments have you done so far? You did the vernier, you did this micrometer, and then you did the
For the free fall.
free fall. You did, and then
I think that was it.
that was it. Okay.
So it'll be number 4.
The 4th one. Yeah, you'll do a couple of labs this semester, and yeah, this is the 4th one. So write down the 4th. The free fall was your home, right? Home work.
Yeah.
Okay.
Do you just want our name like in the top right header?
Yeah.
Or,
Yeah.
Okay,
That's enough. Yes. Aim of the experiment is this. This is what you're going to the lab for, and that's what you're trying to achieve. Okay. Now, what comes after the aim are the materials used. The next heading is materials used. So, in the lab, what materials are you going to use, or what materials did you use as you did the lab? And those things will be listed out. So what is it? I'm going to use a stand. I'll use a meter stick. And I'll use this unknown mass. I'll use a known mass. And I'll use this clamp. I'll use a beaker. Okay, you know, when you do the lab, you can list whatever you've used. I'll be using some thread. I'll be using scissors. Whatever you use in the lab to complete your work. I'll use some water. Okay.
When we write the materials used, you just want us to list it, or do we have to write it in a sentence?
No. Most of these things you can put it in bullets.
Okay.
That'll look easier to read. I don't like paragraphs personally, so don't write any paragraphs at all anywhere. So just put them in list form. That's better. Okay. I don't mind about materials. In materials, you can actually do that. Now, some students, what they do is they put a picture of a small picture of each material as they list it. That's nice, because then that gives a visual explanation of what you're doing.
Would you want us to take a picture of it, like in the lab?
That can be done. You can do it that way. Now, those pictures that you're attaching are, those pictures will definitely help explain the lab better. So if you are having those pictures put into your lab report, the benefit of that is, if I see some other mistake in the lab, I will just oversee it. You understand? So if there is a mistake in the calculation, and I won't be, cutting points on that because you've done something else, that's good. Make sense? So if you already put your efforts on some areas, some other areas I will overlook, and so you can get a full score on it. 20 points of test points. Remember this. So you do the lab report properly, and I will give you all of it. The only time I take points off is when I don't see students putting their effort in, and then there are no units, there are no, things are not written as I expect you to write in a normal lab report. So what is a good lab report? A lab report should be a report that some lay person should be able to read it and understand clearly what happened in the lab. Do you understand? Like if your mom has no idea of physics, but you give your lab report to your mom and then read it. Your mom reads it and understands a lot of stuff as to what exactly went on in the lab. That is a good lab report. Okay. What comes after materials used is the theory and formula used. Theory and formula used. In this, so this lab is based on what? Principle of moments. Now, what is the principle of moments? It is just like a balance. You see, this meter stick is now balanced at the center of gravity like this, right? Remember I told you about the seesaw? If someone is sitting here it's going to create what kind of torque? Clockwise torque. And if somebody sits here, it produces counterclockwise torque. Now, if two people are sitting, one here and one there, and if it is still balanced, what do you know about the net torque? Zero. That is principal moments. What is principal moments actually trying to state? The clockwise moments will be equal to the counterclockwise moments if it is in equilibrium. That is the theory. So in the theory, this is what the theory is. When you have a beam balanced like that, if there's a force acting here and the distance is d1, and if there's another force acting here and if the distance is d2, F1 d1 is the torque, right? Force times perpendicular distance. So counterclockwise torque is equal to clockwise torque. That is the principal moments. This is the principal moments. When is this true? You have it. When is this true? Counterclockwise, you have to have your pen in your hands and write stuff on paper. You can't do this. That is, I'm not dancing over here for you to enjoy your program. You have to write down stuff. So this is a condition that will be true when an object is in equilibrium. Equilibrium means balanced. Okay, that is your theory. So this picture will be helpful in the theory to explain what the theory is all about. Now the formula that you're going to use is this. F1 D1 should be equal to F2 D2. This is pretty much what you're going to do in the lab. F1 D1 is equal to F2 D2. That's your theory. Okay?
Is that the formula or the theory?
Yeah, that's a theory. That's a formula. The theory part of it is right there. This is called the principle of moments. So the theory is principle of moments. Here's the principle of moments. So you're trying to understand how the principle works. When something is balanced, the total moment should be zero. The torque should be zero. So this is what you need to write for the theory and formula used. Any questions about it so far? Okay? Clear? Good. Now what comes after the theory and formula is the procedure. So let me write down what is expected for normal experiments, for other experiments as well. This is what is expected. Procedure. What comes after the procedure? So what is procedure? Procedure is writing a list of proceedings in the lab. So when you went to the lab, what did you do? You took the meter stick, you did this, you hung it, and you took the mass, you measured this. So any step that you have taken in the lab, those are all going to be recorded under the procedure. And as he was asking, make it bullet types. It'll be easier to read. Normally procedure will go to half page easily because it tells exactly what you are doing in the lab. Now, imagine you write a procedure saying, I went to the lab, gathered the instruments, worked with it, and got the results. That, give it to your mom and ask, like, can you read this and understand what I did in the lab? That will not tell anything, right? Yes.
So in the lab, are you allowed to record each step you take in order to use it in your lab report? Is that all right?
Yeah, you're writing down each step.
Write it
Yeah,
down
you can,
steps,
yes.
so you don't
But you know what? It's just, it will come automatically. You do the lab, you go home and just recollect it, you'll get it all.
Okay.
You will be able to remember exactly. That's the benefit of doing something. You will remember everything step by step. So you will be able to generate a nice lab report if you do it the same day. Now, if you wait until a week and then, oh, what did I do? Oh, I forgot. You won't know what to write after a week. So the best thing to do is the same day before you forget, or same time. But it's kind of difficult at the same time, writing something out, because you're interested in taking measurements, and then the writing part of it will be burden. Okay, so procedure is normally what is written. This is for a normal lab, okay? I will change these for this lab. After procedure comes observation. Now, what is supposed to be observation? It's a list of data that you have picked up. It's a list of data that you have picked up, which normally comes in the form of table. Normally, data is best represented in a table, right? You can put so many numbers, all the measurements that you've done can go onto the table, and the table can go to half a page or 1 page, it depends on the experiment. So observation normally is in the form of a table, but for this experiment it is not on a table, and I'll change it there. What comes after that is calculation. So what is calculation? Calculations are the steps that you are performing to use the data from this table into the formula that you have said here, and finishing off, finding out something, right? Write it down.
What did you say it was?
Yeah, calculations. Here you need to show how this formula is used, and this data goes into the formula to get your final results. So all the calculations goes here. So like, for example, what am I asking here? Find the mass of an unknown object. You can definitely do some calculations. That goes there. Relative density of the object. That goes there. Find the mass of the meter stick. All the calculations that follow, that goes there.
How would we list that? Like,
Do you do the calculations? Like, for example, the calculation is, if you want to find the volume as length times width times height, I'm just giving an example. If you want to find, this is the formula, right, for the volume?
Yeah.
Now, in the calculation, you put this formula down, and then you say 5.35 times 1.27 times 5.38. Show this, and then finally the answer, centimeter cube. Like this is what we call as calculation. Okay, so after you put all these things down, then you do your calculations on a calculator and put the answers here. You get it? But why are these important to be put, why are these put over here? Is because in case there is some mistake over here, I can go back to the previous step and find out what numbers did you actually use to get the volume. It is possible that you have picked up a wrong data from the table, and that is why the answer is wrong. Okay, so I can correct you. Now, if you just write volume is length times width times height, and it is so much, then I can't find out where the mistake has happened. So you need to show the steps that goes there. So calculations, it shows all the work that you've done. What comes after calculations is precaution. Now this is a lab report. You need to produce this report in order to explain what exactly went on in the lab. That's why we're writing all these things in this format. Now, is this format an international format? Not necessarily. There can be other schools following slightly different formats, but all these things must be there. It should be there, because if you've done a lab, it will have all these information. Calculations, precautions, maybe the titles are titled differently, but the same thing. Precaution. What's precaution? Precautions are steps that you need to take to make your experiment error-free, right? So what did you do to ensure that you're getting a right answer? So what are the steps? Like, for example, if you're going to use a scale, what is the precaution that you need when you're using a scale? Yeah.
Zero down.
Zero down the scale. So tear the scale. So don't just blindly use a scale because it could be reading something. and you just go and put the object, then you're going to get a wrong answer. So make sure the scale is zeroed, and make sure the scale is reading in grams. Sometimes it can be reading in other units. So make sure it is reading in grams. So those are the kind of things that you write in the precaution area. You get it?
Are you
But-
recording all this
I am.
on there?
Wait, so in the precautions, we have to write like the steps we take to make sure there's no errors.
Exactly. And sometimes in some experiments, you need to write the precaution this way, repeat the experiment 3 times at least, you know. If I want to find the time it takes for this to drop from here to here, I can't just do the timing once and finish with it. No. That will involve error, human error. So how do you get rid of human error? Repeat it, repeat it, repeat it. And then you'll get a bunch of readings, then take an average. So that's one of the precautions. And multiple precautions, like when you're using this beaker and stuff like that, you can break stuff. So you have to write down some precautions to make sure that everything's all right. Okay? So when you do the experiment, you will know what exactly you are taking care of, and then accordingly you write your precautions. What comes after the precaution is conclusion. That is giving you a wind-up of the entire proceedings. So in the conclusions, there are 2 types of conclusions basically. One is trying to say, what did you find? Because in the aim you said, I'm going to the lab to find this, this, this. In the conclusion you say, I used the principle of moments and found the mass of the meter stick and the object of this mass, and I found the relative density to be so and so, right? And the second part of the conclusion will be an impression about how the lab went. Did you gain any experience out of the lab? Did the lab, did you find the lab useful, helpful? Okay, so any impression about the lab goes there. That's a conclusion. So this is what generally goes in all lab reports. Make sense? This experiment, we have a little difference here. For this experiment, procedure, observation, and calculations are all going to be written together, because the experiment is such that you can write procedure, observation, and calculations. It's all together, because there are different procedures. Look at this. There are different procedures. You're going to find the mass of the meter stick. You're going to find the mass of an unknown object. And you're going to find the relative density of the object. So they're all different procedures.
So like in the lab report, where we just do like mass of meter stick, then or like procedure, mass of meter stick, and then give the procedure for that.
Exactly. And then go to the next one. So basically you have 3 different procedures.
And then 3, okay.
Okay? You get it? All right, I'm taking this off. The rest of this is exact. So I'm going to explain to you how this whole lab is supposed to be working, and I'm going to demonstrate it to you here, right here. So before you start the lab, the first thing that you're supposed to do is, this is a preliminary procedure, like a basic procedure that should be done before you start the lab, which is, I need to find the center of gravity of this meter stick. I need to find the center of gravity of this meter stick. So to find the center of gravity of the meter stick, what you do is, you need to suspend the meter stick. So I'm using this clamp. Look at this clamp. Can you see this thing here? So I put this in. Huh? Yeah, I put this in, clamp it up. Now I need a piece of string. We're going to use strings to support the meter stick. Now, a string, do you know how to make a noose?
A noose?
Yeah.
No, I don't have to make one.
You need to learn how to do these things. One day you may have to use it.
It's fine.
One day you need to know how to do these kind of things. See, that's a noose. So, not for anything else, to hang the meter stick. Not for anything bad, okay? Alright, so here's a meter stick is now hung with this. Now, how do you suspend this one over here?
Tie another noose.
Not necessary. You can just open this clamp over here and slip this thing in, and then after that tighten this up. That's more than enough. Of course, you can just twist this around to make sure that it's not going to fall off. It's over.
That
Tighten.
looks so easy.
Now, is this meter stick balanced?
No.
No. That is your first job. So this is a cleanly tied noose. Can you see that? It's very. Now this string has to be absolutely vertical when you're doing the job. The string has it can't be like that. That's one of the precautions. Okay? Do you understand that? That's one of the precautions. You are supposed to make sure. Now, what do you do to get it back? Why is it tilting this way? Is because the weight of the meter stick is acting somewhere here. That is making this meter stick rotate clockwise. So that's why it is falling this way. Right, Colton? Got it? Then, so if it is falling one way, you move the same way. You move the same way and try it again. No. Try it again. No. Keep going till you reach equilibrium. It's still going? Yeah, ask me any questions if you have any. Great. So this is absolutely, I got the center of gravity. That's your first job. Your first job is to find center of gravity position.
So that'd be like the first step.
That's your first step
procedure.
in your procedure.
Shoot, what you're saying. All right.
That's your first step in the procedure. That is to detect the center of gravity position. So what do you do for that? What do you write in the procedure part? What do you write in the procedure?
Center of gravity.
No, you suspend the meter stick and scoot the loop. Okay. Yeah.
Wait.
Yeah, the
So
loop.
wait. So you have to have like sub steps of the initial step.
Mhm.
Ooh, all right. I did it.
So what are you going to write in this part of the procedure? So this will be your basic procedure for the rest of the objectives. So center of gravity position, how do you get it? You write down a couple of lines about what are you doing here. You'll say tie a string, suspend the meter stick, move the loop until the meter stick establishes equilibrium, right?
Will those all three be different steps?
Yeah, they're all different, yeah.
Okay.
So write this first, and then you're going to draw a diagram. Show the meter stick and where the string is attached. And on the meter stick, you can say 0 centimeters here, 100 centimeters here. Did I put it right? Yep, that's 0 centimeter for you, and that's 100 on this side. And then this is the center of gravity position. How much is that? You have to exactly write down. This is 49.9. So I have balanced it at 49.9. That's the center of gravity position. So what do you write here? A couple of lines of what you're doing, right? Diagram. And these numbers that you put on the diagram is your observation. Do you get it? So not a table observation. This number itself is your observation. Finished. Now, there's no calculation here because you already wanted to find the center of gravity. Boom, done. You have found the center of gravity and over.
Wait, so that's our observation?
That's your observation. Or putting down these numbers is what you're observing
You
in this
put
experiment.
down those numbers?
You will put down those numbers on the diagram. Now, in a minute, I'm going to show you how to make the lab report. How to draw this diagram. Yes. Yeah, I'm going to show you. Don't worry. Do you get this first thing? And then you go to the next one, which is mass of the meter stick. So for the mass of the meter stick, that's your next procedure. Mass of the meter stick. What do you do? This is what you do. Look, I'm going to work it out. I need another string.
Mr. Sam,
Yes, go ahead.
as far as you said the aim, you said there was only three. There was mass of meter stick, mass of an unknown object, and relative density of objects. So
Yeah.
I mean, there are four.
You can write it as 4 actually, but because center of gravity is something that's very basic, which is required for all the other
So
parts.
technically, there's it's gonna be 4.
You can write it as 4.
All right.
Do you want to write it as 4? You can write it as 4. Find the center of gravity. Find the mass. Yeah, just make it 4. Can you?
Okay, I got you.
Now you make for the second part. You do this. You need to make 2 nodes on both sides of the string. Those are not good today. All right.
This is for mass of a meter stick.
Yes. So I have made 2 of them. On one side, I'm going to put that guy.
That's
And-
a dirty little laugh.
And then I'll suspend this on one side. So I'm going to suspend it at a definite spot, which is, let's say, at I'm going to put this one at 1 centimeter mark. See, can you see that 1 centimeter mark there, right there? Now, the more precise you are on putting these strings, you'll get good results. Very good results.
Would that be a precaution?
Yes. Make sure that the string is perfectly lined up with a certain marking, because that's important. You can't just do something rough. So I put this thing over here. Now, unfortunately, this thing is a little too long, so what I can do is I can just raise this up. Okay? I can raise it up. I can raise it up further.
Hey.
Now, is it balanced?
No.
No. So what do I have to have, because it's tilting this way?
Put another one on that side.
No, you just have to scoot this here, like that. See, this is your procedure. What do you do? Suspend a known mass of 100 grams on one side at 1 centimeter mark, and then, now see, this is tilting this way. And I keep adjusting it till I get it perfectly horizontal. Oh, okay. Now it's not horizontal yet.
How much do you say the weight is?
100 grams.
100 grams.
So this is not horizontal yet, so I just make sure that it is perfectly horizontal. Yeah, leave it there. Yeah. Make sure it is perfectly horizontal. If it is perfectly horizontal, you're ready to take the readings. Okay, is this almost horizontal? From there, does it look horizontal?
Pretty solid.
I think it's good.
Is it tilting this way?
No, I think it's down on the right a little bit.
This one here?
Just a tad.
Okay. Yeah, you need to make sure it's perfectly, that's one of the precautions. When you're balancing something, make sure that it's perfectly horizontal. Is it? Good?
I think you got it. Yeah.
Yeah. So once you get that, what are you going to do and the procedure? You know what the procedure is, right? Suspend a 100-gram mass on one side, and then what? Move the other string to a spot till the whole thing balances. That's it. That's your procedure. And what do you do then? Draw the diagram. Draw the diagram. So on the diagram, you'll show a string here at the 1 centimeter mark, and you show this the weight that is hanging there. And where is the other string? The other string is somewhere here. Correct? Now, where is it? It is at the 29.8 centimeter mark. It's at the 29.8 centimeter mark. Now, center of gravity is here. The center of gravity is 49.9 centimeter, and that is the place where the weight of the meter stick is acting. The weight of the meter stick acts there. Correct?
Yes.
The weight of the meter stick is mg. Isn't the weight mg, mass times gravity?
Yeah.
The weight of the meter stick is mass times gravity. Where is this thing? Okay. The weight of the meter stick is mass times gravity, so that is there. Now tell me, how is this in equilibrium? You know, I told you what is equilibrium. Equilibrium is when?
0.
The total torque is 0. So this thing is trying to tilt this meter stick for you counterclockwise. What is trying to turn it clockwise from this side? What is trying to tilt this meter stick clockwise? The weight of the meter stick, which is acting somewhere here, right? So the weight of the meter stick is acting as center of gravity, tilting it this way, and this is tilting it this way. And what's the principle of moments? F1 d1 is equal to F2.
F2 D2.
That's it. So what is this here?
100.
Now what, you can keep them in grams. It is fine. If you want to leave them in grams, it's okay, because since you're writing F1 d1 and F2 d2, you can leave it in grams. So what is this? It's 100 grams times the acceleration due to gravity. Correct? And this is m grams times the acceleration due to gravity. So what is this distance from here to here? What is that distance?
28.8.
28.8. And what is that distance from here to here? How much is this?
20.
20.1. So you have it. What's your principle of moments? F1 d1 is equal to F2 d2. Therefore, 100 g times 28.8 is equal to mg times 20.1.
So would that be a calculation?
That is your calculation. Look, you write observation 2, 3 lines, draw the diagram, observation is right there, the numbers that go in there is your observation, and that's your calculation. That's why I said you can put all those together. Now, g's cancel off, gravity is the same. What you're trying to find out is m, right? So what is m? 100 times 28.8 divided by 20.1. Can you tell me how much it is? How many grams it is? Work it out. Calculate it.
143.
Quick. How much?
143.28.
Yeah, 143.3 grams. This is what you ended up getting for the mass of the meter stick. Now what do you do after this? Remove the meter stick from here, take it to a scale, and check it. So you can just compare it. M actual is equal to, you'll be surprised, it will come almost the same number. Say, for example, I'm just giving an example, 143.2. That is the actual, and this is what you ended up getting. Normally, students get very close answers. You understand what I did here?
What did you do?
I removed the meter stick, and I took the meter stick to a scale, and I weighed it. This is what you calculated. This is what you weighed.
Just meter stick alone? Or
Only the meter stick.
Okay.
Because this is the mass of the meter stick, you got it there.
What does that say? Does it say
M actual.
M actual?
Actual mass.
Oh, actual mass.
Okay? Do you understand that step? Now the next step is going to be this. Remove this mass. Remove this mass and put this mass, which is your unknown mass. And do the same thing over again. Just do the same experiment once again. But this time, you know the mass of the meter stick. But you don't know this. Do you understand? So the third procedure is going to be this. You balance it once again. And once it balances properly, you go ahead with the calculation. What's the calculation for the next step? You do the same stuff. The calculation for the next step is this. You don't know this, so call it M. But you know this. So it's 143.2, right? Use the actual one. And then do the calculation again. So it will be mg times, now of course these numbers are going to be different. Those numbers will be different. So it will be mg times d1 is equal to 143.2 g times whatever d2. And then calculate this. What will that be? The mass of the unknown object. What do you do after that? Take it out from here, take it to the scale, and weigh it. So you will know the actual. Do you understand what I'm saying? And the last step is to find the relative density of this. You fill this with water. Fill that much with water. bring it here, and then keep it inside. So that now the mass is going to be submerged. It's a little tricky because it should not be popping up or touching on the beaker, so you may have to adjust the heights. But put it inside. Now I'll not put water right now. So when you put water, what will happen? This will weigh more or less?
Less.
Less. So automatically you will have to readjust your positions until it balances. Now when it balances, you're going to make sure that it is perfectly inside the water, not looking out of the surface or touching on the sides or anywhere. It should be inside the water. And once you do that, your calculations go like this. This is going to be the mass underwater, the apparent mass underwater. And you do the calculation once again, you find MW. And your final answer for the relative density is this. Relative density is the mass in air divided by the loss when you put it into water. You do this and you get the relative density. That will be the density of this material. Get it? Now I'm going to show you quickly how to draw the diagram. Any questions here? Yeah.
What does RD stand for? Oh no, that's the density. Isn't
Relative
it?
density,
Okay. Yeah.
which means like how many times denser is it compared to water? How many times denser it is compared to water? That is what it is. I'll show you how to make the lab report. Let me put this here. Alright, let me show you this.
Should we hit the lights?
You need to put off the lights, yes. Go ahead, turn the lights off.
Just some mood lighting.
I don't know.
Take that picture.
Okay, that's good. Okay. So what we do, I'm going to take a little time to finish off this now. What you do is open your Word document. This Word.
Word document right there. Right next to PowerPoint.
Beside PowerPoint? Under
straight
your
up.
email?
Oh, that's your email. It's Outlook.
It's Outlook.
God's loves.
So underneath the mail.
Up.
Up.
Go up. Straight up.
Oh, yeah.
Right there.
Yeah.
Boom.
My eyes, okay. So I've got the Word document opened up. Now what you need to do is drawing, right? Main challenge is a drawing. This is how you do the drawing. Click on insert. Okay? Click on insert and draw no. Insert. Pictures, no. Okay, here, shapes. Click on the shapes. And on the shapes, you can take the cube looking like object. Now, once you get that, you get the cursor changed like this. Click, drag, and drop. Of course, the shape, the color is not looking good, so you just go to the color and change the color.
Do a little orange.
Yeah, you can.
Maybe a little Gringo rocks.
You got it?
Yes, sir.
Now, how do you suspend the meter string by strings? Go to insert again. Everything is in insert. Go to shapes once again, and take just a straight line, and just suspend it.
That was so hard to see.
You said no tables for this
No tables.
lab, right? Okay.
But the drawing is this. Now, how do you put the numbers here, like 0 here, center of gravity here, and that one there? To put the numbers, what you do
Trouble with text box.
is use text box. That's the best thing to do.
Yes, sir.
Okay, so what you do is insert, everything's in insert. Insert, text box, just take the simplest text box
Freak yeah.
and make it a little smaller, drag it to this location, and right there, click on it and write 0 centimeter. But this doesn't look good because it kind of blocks the entire thing.
I don't like it.
So what you do now is right click it, and can you see here it says format shape? Click on format shape and go to fill and say no fill. And then go to line and say no line. And then you see what happened there.
Do you have to do this for every single text box?
No, now you can copy the same text box everywhere.
Crazy.
How do you do that?
Fancy in here.
Click on this text box, right click, copy, and then you want to paste it. So right click, paste it, and then take that and drag it to wherever you want. So you want to put here center of gravity, put here center of gravity equal to 49.9.
Nice.
You get it?
Yes, sir.
Now right click anywhere, paste it, drag it again to the other point, and write 100 centimeters. It's pretty easy.
Yeah.
You understand so far?
Yes, sir.
Good. Now, once you do this, this is how you make it. Now, what do you do for the second part of the thing? You have to scoot this to the right side. And then you need to put one more string. You need to put one more string here and suspend it. And suspend what? You need an object. So go to
Get you a
insert,
circle.
take an object. Like, okay, for the last one, you can take an object.
Circle.
Let's take that and put it here. And there is my object.
Oh.
That's my unknown object. Now, if you want to put a beaker, then go to insert. Now, remember, these are going to be there for, like, you're going to have 4 pictures, right? Now, if you want to put a beaker, go to insert, shapes. Watch this. You're going to take a beaker, that is the cylinder. Take the cylinder, click somewhere here, and then drag it. And then drop it.
Oh.
Now again, once you dropped it, you don't see the smiley inside. You don't see the smiley. Smiley's
I want to see
gone.
a smiley.
And what do you do for that?
I don't know what.
Right click it, format shape,
No fill.
go to fill,
No fill.
and then you can put transparency. Just transparency. Right? Now you got that there.
Yes, sir.
And the next time you want to make a picture, right click on this meter stick, copy, and then paste. And then move that meter stick to wherever you want.
Look at that dirty little lad.
You're gonna do it here.